Today we will discuss probability. It's a new chapter on the business strategy subject. The probability, and simply we tell it, we are quantifying the uncertainty. Uncertainty, it is something that may happen or may not happen, but we don't know what will exactly happen. So quantifying uncertainty for managerial decision making. So this probability, application of probability, it is necessary for managers for decision making at the time of uncertainty. And what do you mean by certainty and unknown? Certainty, some events we know 100% that may happen, that will happen 100%, no doubt. For example, when we throw a coin, right, or when we throw a ball toward the sky, right, we throw a ball toward the sky, the ball definitely will come down. So 100% chance. So that is certainty. That is certainty, right? For certainty, probability is 100. We know that everybody knows 100%. So no doubt. There's no doubt. And unknown, right? Unknown. You toss a coin. What is the outcome? So there are two outcomes. Either you can get head or tail, the tossing a coin. The unknown, so we know the outcomes. We know the possible outcomes, head and tail, but we cannot exactly say, we can't predict exactly the result, head. So if before I toss the coin, if I say the outcome will be head, so it's unknown, we don't know. We realize it after tossing the coin, the result, after obtaining the result. Before toss the coin, we don't know head. Either we get head or tail. So that is unknown. The risk mean the managers will take decisions about the future, but that decision may give a positive, favorable outcome or unfavorable outcome. So that is risk, right? Managers, for example, managers decided to buy some stocks in the stock market. They think that the price will go up and we can earn profit. But it's not true, right? It's not 100% sure. Sometimes the price may fall down. When the price fall down, the company may face a loss. It's a risk. It's a risk, uncertainty, right? And we are the risk arises due to uncertainty. A company introduces a new product into the market. New product. What is success rate? When the company produces and introduces a new product, it make a lot of investment. It make a lot of investment to develop that product. If the product got failed, whole investment will be wasted. So that is what uncertainty. For example, we can say you might see Google Glass. This kind of product introduced by Google. It's a digital glass, so you can wear that glass, and that right, it's a digital glass. So you can access all the digital features. But even after, right, the Google totally lost the investment on this product. So product failed. Even today, if you search in the internet, you can't see the images of Google Glass. So that's a utter failure product of Google. So it's a risk, So the billions of millions of investment made on this product but failed. That's a risk. Probability. So in forthcoming sessions, we always most probably will use the term probability. What do you mean by probability? Probability. People say chance, chance. Before start the cricket match, India and England, India versus England, some people predict, right? India will win the match. But the chance, what the chance of winning cricket match, winning this match against England? India's probability, winning chance of India winning chance. So the chance, right? The chance is measured in terms of some people say there are 60% chance. India has 60% chance of winning the match and 40% chance of there are 40% chance for England for winning the match. So now we convert this chance, right? We assign some values for the chance. So that is called probability. The chance is an uncertainty, no? Chance. We don't know until finish the match. We don't know who is going to win the match, right? So we assign some of the values for the unknown. Right? This unknown is got measured. Then we call them as a probability. Right? Here, probability, the definition of probability. Probability of occurrence is the chance that a specific event will happen. So that's a probability, right? Probability of occurrence is the chance. The chance got some numerical value, right? That's a probability. So probability is the measure of uncertainty. Probability is the measure of uncertainty. Before we toss the coin, we don't know exactly do we get the head or exactly we get the tail. We don't know. After tossing the coin, we can realize what is the output. It's uncertainty. We can't sure. Before, right? Before we purchase the share, we don't know whether the price will go up or go down. We know after some period. So after buy, we only know that price go down. It's uncertainty. And when you get the Mahajana Sampatha ticket, before they run the balls, we don't know. Right? We don't know what is the result of this day. So what is the winning chance after that ticket? Do we win? Do we win or not? If we win the game, we can get millions, sometimes billions, right? If we lose the game, we lost only 40 rupees or 50 rupees for that ticket. Right. So context, in what context we use this probability? In our everyday life and business, we use it constantly, often without realizing it. Many people don't know what's the meaning of probability, but they are using. Say even the farmers, they can predict tomorrow will be the rainy day. Tomorrow will be the rainy day, or tomorrow will be uh, no rainy day, right? Tomorrow will be, tomorrow will not be a rainy day, or tomorrow will be a rainy day, right? So the farmers, they are using the probability, but even they don't know. Fishermen, they can predict tomorrow there will be a cyclone, right? Tomorrow the sea will be rough. Fishermen predict. There are chances of become the sea become rough. And many children, right, in the school, they can predict, they can use the probability. Today, our class teacher will come to class. Or there are chances that our teachers may not come to the class. And students, they can measure the probability, right? They can use the probability that I set the exam very nicely. So I have 80% chance of getting A plus. I have 10% of the chance of getting B, right? So there are chance. I have only 1% chance of losing this game, or I have only 1% chance of losing that exam, failing the exam. Some students are in the middle. I have 50% chance of passing the exam. I have 50% chance of failing the exam. And even without know the term probability, they use in their day-to-day life. What the purpose of studying the probability and applying the probability? To transform watch uncertainty into calculated metrics, right? So the chance, no, the chance. Some people say, right, India versus England match. Some people say India has more chance than England. India has less chance against Sri Lanka. Chance. Then here we use the term more chance, less chance. So it's qualitative. That is, it's a qualitative matrix. Then if we say, right, there are chance of 60% chance, 70% chance. So it's exactly right. It's a kind of measure. It's kind of measure. So though, right? So it's a wage, right? The uncertainty is a wage. It's a watch, right? So to transform the watch uncertainty into calculated metrics. So right. So it's very important. So the calculated metrics is important. Right? Probability can be measurable. The chances can be measurable. Right. We know. Right. There are two extremes. One is impossible. Right. One thing is impossible. One is thing is the another extreme is 100% sure. Any event that we can say, any event that may happen is certain, it's 100% sure. 100% sure. Say you throw a ball toward the sky, definitely the ball will fall down. When you toss a coin, definitely you will get head or tail. Definitely you will get head or tail. 100% sure. But right, 100% sure, we assign the value 100%. 100% sure. 100% sure. Something, right? Something impossible. Impossible. Say, when you toss a coin, is it possible to get head and tail at the same time? When you toss a coin once, right? You toss a coin once, the result become head and tail, right? Zero chance. You may get head or tail. You can't get both at once. So that is what? Impossible. This is impossible. So impossible, 0% chance. 0% chance. We measure the impossible. We assign the value impossible 0%. So there are two extremes. Impossible and possible, certain. Right? Not certain, right? Not possible. Certain. 100% possible. 100% certain. Right? 100% certain. So that we 100% sure. It's so that here 100% total outcome and 100% sure. Then what the result? Equal 1. So the maximum, the extreme value, right? The maximum measure of probability is 1. That is 100% sure. No doubt. We have no doubt on the outcome. That is 1. 0 for impossible, we assign the value 0. How? Out of 100%, 0% chance. 0% chance. So therefore, we will get 0. So therefore, the the spectrum of certainty is range from 0 to 1. Sometimes it may be converted into 100 percentage. 0 to 100 percentage. And when you toss a coin, what's the chance of getting head? What's the chance of getting tail? When you toss a coin, there will be two outcomes. Either you can get head. What's the chance of getting head? 50%. So therefore 0.5. What's the chance of getting tail? Out of two outcome, head and tail, two outcomes, only one outcome we can get. So 50% chance. That is 0.5. Right? So those head and tail equal likely. Right? Equal likely. And today you see the sky, right? The cloud, you can see only the white cloud. You couldn't see uh, any sign of raining today. Then you can say, right, today there are 80% chance of not rainy. The day will not be a rainy day. But when you look at the sky, right, you can see the black clouds, the dark clouds in the sky. And you can say, right, today a 90% chance of getting rain. So these are chances, right? This chance. The key rule, probability, always we use the letter, right? The P for probability. Probability P always varies from 0 to 1. Inclusive. Inclusive mean probability sometime equal to 0. Probability sometime equal to 1. But it's range, right? So when we write this, probability, right? Probability 1 no equal to less than 1 or equal or 0 or more. Here probability is 0 or more, probability 1 or less. So this is the rule, key rule. The probability can never be more than 1 and less than 0. It's mean probability never be negative. That's the key. Defining the universe of possibilities. Yeah, universe, right? Universe of possibilities. And we should know some key terms, key terminologies. Random experiment. Random experiment. Random experiment is the input experiment. Each experiment will provide some outcomes. Each experiment will provide outcomes. That outcomes we call sample spaces. So all possible outcomes, we call them as sample space. Right. Let's see what is a random experiment. A random experiment. You toss a coin. You toss a coin. We don't know what is the exact outcome, but we know the possible outcomes, head or tail. Head or tail, that's a possible outcome, but we don't know what is the exact outcome. The outcome is random. The outcome is random. We don't know. We don't know. So that's a random. We don't know the result. Right? Any experiment processing, any experiment process, right? Any process generating result is an experiment. It's a random experiment. Any process generating result, that is experiment. Tossing a coin is an experiment. Customer arrival, right? For a shop. Today 9 to 10:30. How many students, how many customers will come to the shop? We don't know. But we can say average, on average, there will be 50 customers will visit our store. There will be, right, in today's class. In today's class, how many students will attend? On average, we can say 70 students can attend today's class. But sometime it may be more or less, 65 or 70, 80, 89, 90, 100. So that's an experiment. That is a random experiment. Machine production. A machine, say photocopier or printer. Today, this printer will get will print 100 papers. Sometime there will be a huge queue. So on that day, the printer may print 1,000 papers. Sometime the printer may got zero papers printouts. So those are what random experiment. We don't know the exact outcome. That is random experiment. And in each and every random experiment will give an output. So input is an experiment, right? Experiment is an output. Experiment, random experiment is an input. And each experiment will give us a possible outcomes. That is output. So this output is called sample space. It refers as term E. When you toss a coin, what are the possible outcomes? Head or tail. These are the possible outcomes. So we can write them as probability of tossing a coin, head, comma, tail. These are the sample space of tossing a coin. The set of, what do you mean by sample space? The set of all possible outcomes. It's called sample points. Sample point. Head is a sample point. Tail is sample point. So those are sample points. Sample points. And we see one more example. Throwing a six-sided die. Throwing a six-sided die. You know the die. Six faces. It has six faces. When you throw a six faces die, what are the sample space? Sample space means the possible outcomes. Either you can get score 1, score 2, score 3, score 5, score 5, score 4, 5, 6. You can't get score 0 or 7 or 8. You can't get. So 0, 7, 8, 9, 10. All these values are not sample space. So the sample space is only the possible outcomes. Possible outcomes. We use the curly bracket. Sample space, we use the term E, 1, 2, 3, 4, 5, 6. There are 6 sample points in this set. And another term we use, event. Sample space and event. An event is a subset of all possibilities. So this event is a subset of all possible outcomes. Right? Event is a subset of all possible outcomes. When you throw a six-face die, right, you can see the sample space, all possibilities, the sample space, the possibilities, 1, 2, 3, 4, 5, 6. Right, 1, 2, 3, 4, 5, 6. Right, there are some mistakes here. 1, 2, 3, 4, 5, 6. 5 is missing. Right, so there are some issues here. What are the possible sample space? 1, 2, 3, 4, 5, 6. So these are the possible outcomes. What is subset? This is a set. The possible outcome, these are the possible outcomes. Out of these possible outcomes, we get one score. Say, the event A, we define an event A. So we'll get score exactly 4. Exactly 4. So one event event A is exactly 4, scoring exactly 4. Right, we can say in that way. So in this instance we get only one outcome, one score. Or we can say the probability of getting probability of getting even numbers. Probability of getting even numbers. Even numbers, you see here even numbers. What are the even numbers? 2 is an even number. 2 is an even number. 4 is an even number. 6 is an even number. So we can write like this probability. So we can define that event B, right? Probability of, right, event B, right? Event B, even numbers 2, 4, 6. Here, this event has one or 1, 2, 3. There are three outcomes. There are three possible events. There are three possible scores. So if we get more than one score, more than one elements within their uh, events, it is called compound events. It's called compound events. Here 2, 4, 6. There are more than one. If we have only one score, right? One score, it's called simple event. Simple event. So the term word, you should know the differences between simple event and compound event. When we look at the definition of event, an event is a subset of all sample space. So when we draw it in a Venn diagram, 1, 2, 3, 4, 5, 6, right? Here even numbers. So this is the all opposite outcomes. No, this is a set. It is a set. Then 2, 4, 6. It's a subset. Subset of all possible outcomes. This is an event. Right. In probability, there are three approaches. We should understand these approaches. It will help us in the forthcoming sessions. Number one, the approach, classical approach or axiomatic. Number one, classical or axiometric. Sometimes called theoretical, right? So theoretical approach. It emphasizes an equally likely. Each outcomes, each outcomes of each outcome of a random experiment got equal chances. Say, when we toss a coin, the probability of getting head 50%, probability of getting tail 50%. So each outcome, right? There are all possible outcomes are head and tail. Each outcome, right? Each score we get a 50% chance. When we throw a six-face die, there are six outcomes, but there are six possible outcomes, but at a time we can get only one score. So here probability of getting score 1 is 1 over 6. Probability of getting 2 is 1 over 6. Probability of getting score 3, 1 over 6, right? For all outcome, we have equal chances. Second, relative frequency or empirical. This means based on their past experience, we can say, right, it is happening. It may happen. For example, Sri Lanka versus India. Most of the time, Sri Lanka will win the. So no, right. When we look at the past history, most of the time Sri Lanka won the match against India. So it's mean. So based on the past experience, we can predict that yes, in tomorrow's match, Sri Lanka will win the match. It's based on what? The past experience. Here we can't have equal likely. So equal likely is the first approach. That is theoretical. It's empirical. Empirical means the experience, the past past experience, past occurrences. When we run the photocopier printer, there are chance of getting jump, paper jump, right? Out of when we print 10 pages, 2 pages will be got damage, jump, paper jump. So we can predict that, right? When we are going to print 100 papers, there will be a chance of 20 paper got jump. So how you can predict? How can you say there will be 20 papers will got damage based on your past experience, past occurrences? Third, subjective, subjective, personalistic. Here, we have no experience, and also it has no equal likely. For example, a company is going to introduce a new product. What's the chance of making sales? The success rate? How many customers will consume this product within the first day of introduction? When you introduce a new software, how many people will download it? You don't know. Why? It's a new product. It's a new product. But who can say? An expert can say. Experts, right? Expert can say, right? For the first day, 20 people can download. If we promote, 20 people can download. But it's not based on the past experience. It's a personal bias, personal idea, personal, personal thinking. It's a subjective. It's based on a subject to the expert, subject to the expert. So beliefs and confidence. So these are the three uh, approaches of probability. Let's see the classical approach, classical or theoretical approach, axiometric approach. Concept is priori probability. We know, already we know. Say when we toss a coin, there will be two outcomes, head or tail. But each, right, each when each in each toss we know either we get head or tail. The chance of getting head is 50%, the chance of getting tail is 50%. Everybody knows. So that is right before the experiment, we know the probability. Before something happened, we know the probability. So the random trial, right? Before we do the experiment, we know the probability. We do not need to toss the coin to know the outcomes. The logic dictates the outcome. So logic, no. So only to write the shape coin, a fairly shaped coin. Key assumption is all events are equally likely. This is very important. All events are equally likely. So when you toss a coin, write each outcomes. Head 50% chance, tail 50% chance. When you throw a die, uh, getting chance of getting score 5, getting chance of getting 6, the chance of getting 6, score 6 is 1/6. Therefore all outcomes, all scores having equal chance. So we can write it, the probability of number of outcomes favoring the event. So we before we toss the coin, we say head. How many head? One. Out of the total outcomes, two. So we expect head. Say head. Or the total outcomes, possible outcomes, head and tail. But only we get only one. So the chance is 1/2. The number of outcomes favoring. So I guess head. The total number of possible outcomes, number, right? So number here, how many? One, two. Possible outcomes are two. Here, my favorite outcome, one. Number two, the second, empirical relative frequency approach. So based on the past experience, empirical. The probability is assigned based on observed relative frequency in the past. Based on the observed. So observed. is very important. Observed relative frequency in the past. Here, a production line, right? The production line sample 100 items. So in 100 item sample, it found 17 items defectives, right? It was experience. What is that? Whenever we produce 100 items, almost 70 items got defective, got damage. So what's the probability of getting defective item? What's the probability of getting defective item? 0.17 or 17%. The observed outcome, right? The total outcome is 100. So we produce 100 units. And what is the defective item? 17. Therefore, the probability of defective item, 17, we expected, and 100 units of output. Say, if we produce 20 or 10 items, if we produce 10 items, there are a chance of getting 1.7 units of uh, damaged goods, defective items. Third, subjective or personalistic approach is based on his experience, not experience, expertise. When a scientist introduces a new medicine to cure cancer, what's the chance of getting success? So uh, before giving that medicine, right, the doctors don't know the probability and certainty. So therefore, the person who invented the medicine should know, because he know the capability and the power and the specifications of that medicine. So the scientist only knows what the of the success rate of the medicine, right? Here the subjective or personalistic. So it personalistic mean it's subject to persons. The core concept is used when an experiment is not repeatable, right? Not repeat. When you introduce a new product, it has no experience of making sales of a particular product. It has some sort of bias. Why? It may change person to person. So scientist A give one suggestions, yeah, one recommendation. Scientist B may give another recommendation. When government proposes a new budget, there are economic experts may give some views whether this budget may be good success for economic growth of achieving economic growth of 10%. Some economists say no, this cannot be, it is worst budget ever, it will never help us to make economic boost, right? So it's a bias. It's assigned based on individual beliefs or their confidence. Their confidence. Example here, advertising impact on a new product launch. Advertising. When they introduce a new product, they do an advertisement campaign for new product. Then nobody knows how many people got buy except that advertising expert. Since it's a one time event, no past experience in a particular product, we cannot use historical frequency. We rely only expert estimation. The formula, right? The formula to calculate the probability is this: the equally likely outcomes. Classical, right? For classical approach, the probability of event S. Here, the number, right? Number of elements in the specific event set, what we want. So, what we expect. What we expect. This is E, all possible outcomes. All possible outcomes. And S is expect. For example, when we throw a die, six-faced die, what are the outcomes? 1, 2, 3, 4, 5, 6. These are the possible outcomes. But I need score. This is what? Sample space. Sample space. But I expect score 5. Score exactly 5. Mean here how many possible outcomes? 1, 2, 3, 4, 5, 6. There are n, e, right? Uh, number of number of possible outcomes in the event E is equal what? 6. And number of S, event S, number of elements in the S is 1. So therefore, we expect this S no 5. So that is equal to 1. And total possible outcomes are 6. Yeah, number of elements in the specific event. Here only one event. Only one event. Or I can say event I expect I define M, right? I define M is event M. M means getting the score less than 3. Less than 3. Less than 3 mean what? 1 comma 2. So the probability of M, we know total possible outcomes, total elements in the possible outcomes 6, and the elements in the event, number of elements in the event is 2. So therefore 1 over 3. This is a formula, basic formula. But this formula applies only for the classical approach. Here application, we see one example. Single variable, one dice. We throw one die. When we throw dice, we get six elements in the event sample space. Event A define event A getting an even number. Right? What are the even numbers here? 2, 4, 6. How many? Out of 6 elements in the possible outcomes sample space, we get only 1, 2, 3. So therefore, n, right, number of elements in event A is 3. So therefore, the probability of event A is here number of elements in event A is 3, number of elements in the sample space is 6. So therefore 1 over 2. Event B, we define event B, getting number is more than 2. More than 2, not equal to 2. More than 2. Here an event defined as more than 2. So it includes elements 3, 4, 5, 6, 1, 2, 3, 4. There are 4. The number of elements event B is 4, and the number of elements in the sample space is 6. So therefore the probability is 2 over 3. Right. This one is only one die. No? So at a time we throw only one die. Here we experiment 2 dice. 2 dice. At the same time, right? At the same time, in the left hand side and right hand side, we have dice. We throw it. In the left hand side, we have white die. In the left hand side, we have black die. We throw. We throw at once. What are the possible outcomes? What are the possible outcomes? Either both, we can get 1, 1. 1, 1. So the score is 1, comma 1. 1, comma 1. Or we can get 1, comma 2. 1, comma 2. Or 1, comma 3. Or 2, comma 1. 2, comma 1. Or 4, comma 4. Like this, we are getting how many possible sample spaces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Altogether 6 by 6. There will be a 36 elements. 36 elements we can write like this. We can write 36 elements. Right? The scenario, a black and white die throw together, and there are 6 ways. Dice 1 and 6 ways die 2, there will be 36 total outcomes. 36 total outcomes when we throw 2 dice at a time. Finding the patterns here equal score. So we define an event M, right? Event M is equal scores on both dice, right? When we throw 2 dice, we need the probability white die 1, black die 1. So equal score. White die 2, black die 2. This one, right? This is white. This is white, no? This is white. This is black. Here the score 1, 1. Right? First white score, white die 1, black die 1. This is 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And these are unwanted, right? This is a mistake. Here, this is our sample space. These are the sample space. Then how many elements in event M? What is event M? Equal score on both die. Here, what are the outcomes? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So there are in the event M there are 6 elements. 6 elements. In the sample space we have 36 elements. So the probability of getting equal scores on both die, a number of elements in the event M is 6 and total 36. Therefore, probability of event M is 1 over 6. 1 over 6. Right, we go a little advanced. The difference, right? We throw 2 dice, black and white. The outcomes, the difference between 2 outcomes equal to, right? How we can get 2? So there are chances. The event here we define an event D, right? Event D is a difference between faces is exactly 2. For example, if we get 6, right? The first in the white we got 6 and black 4. There was a difference 6 minus 4 equal 2. Or this 5, 3. 5 minus 3. This score. Difference is what? 2. And here difference 4 minus 2. Difference 2. 3 minus 1. 2. Or 3 minus 1. Here this one. 2. 4 minus 2. 2. 5 minus 3. 2. And 6 minus 4. 2. Therefore, out of these 36 possible sample space, possible outcomes, we have 1, 2, 3, 4, 5, 6, 7, 8. There are 6 elements. There are 8. There are 8 elements that satisfy our criteria of that event. What's the criteria? The difference of the scores, first die and second die, should exactly equal to 2. The difference between the phases is exactly 2. So the number of elements in event D is 8, the specific outcomes. And the probability of event D, the chance of probability D is 8 over 36, 2 over 9. The probability of getting the differences of 2 between first die and second die. So, right, let's see the summary of today's session. The rule, right, the probability of an event, it's range from 0 to 1, including 0 and 1. And the sum of all possible outcomes, probability is 1. Right? Here, when you toss a coin, there will be two outcomes, head and tail. What's the probability of getting head? 1 over 2. What's the probability of getting a tail? 1 over 2. So the probability equal 1. The total sum of all probabilities equal to 1. Likewise, when we throw a 6-face die, what are the outcomes? 1, 2, 3, 4, 5, 6. What is the probability of getting score 1? 1 over 6. 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 So the total 1, 2, 3, 4, 5, 6. 6 over 6 equal 1. Right? So the sum of all probabilities equal to 1. And the formula to calculate the probability of event S equal the number of elements in event S and total sample space E. So favorable outcome, right? Favorable outcome over total outcomes. And the approach, there are 3 approaches of probability. That's classical approach. This is equally likely. Each outcome here, head and tail, they are getting equal probabilities. 1, 2, 3, 4, right? Each score having equal outcomes. And empirical, so based on the past experience in a particular circumstances, we can predict based on the past experience, we can predict the probability, we can calculate the probability. And subjective, we have no past history to calculate, to guess the chance probability. The experts believes, uh, and the confident may give the probability. Tips for 2 dice: always map the 36 outcome 6 by 6 find your event data set. That's all about today's session. If you have any questions, you can unmute your mic and you can ask.